Welcome, guys, to the next episode on PCAPNG. And in this second episode, we're going to be talking about the interface description block, the IDB. So, we talked in our first episode about what PCAP and PCAPNG are and the reference documents. So, please, if you haven't done that, go back and check out the reference documents. There is several documents available on the web, but some of them are obsolete, and you should point to this latest document here. These were the headers that we described and in our overview, and then today we're going to dive more into detail about the interface description block, which provides the characteristics of interfaces used for the capture. So what the IDB does is that it provides uh, if there are multiple interfaces that you're capturing, for example, from USB interfaces, Ethernet interfaces, Wi-Fi interfaces, and so on, and you want to merge them all into a single file, then you must have a reference or description of what each interface is and which packets correspond to which interface. So the file must contain an interface ID for these different interfaces, and the interface description block here would contain that kind of detail. This is also unique within a section, and so we previously talked about section headers. But within that given section, if there are multiple interfaces, each interface would be unique within the section, but it doesn't have to be unique across sections. Um, so that's very important. It provides the characteristics of the interface on which the capture happens, and it must precede the usage of the interface. For example, if you're using this interface ID for this, let's say ETH0, in EPB or the statistics block, EPB is the packet block, enhanced packet block, or the ISB. If you use them, then you must have IDB before that that describes that. You cannot do a Wi-Fi interface ID some point later without having a section before that. You cannot put it after, for that matter. So that's important. And then the link type, for example, if you look inside this, there's obviously the block type of one, block length. This link type could be lots of different things. Ethernet is the most popular, but it could be Wi-Fi or ATM, RFC, etc. Snap length is just what's the max number of bytes that can be dumped from a packet. And the most important part is this options fields. And these options fields are where we put interesting stuff. And then, as usual, the structure of this header is that there's a block length at the beginning, block length at the end, so you can parse it forwards or backwards without any trouble. Now, as usual, here's the practical example of how the option fields are used. This is from the Wireshark PCAP that's available just by Googling it. I've downloaded a file, and inside that file, you can see that this part here, right after the SHB, this is where the SHB ends and the IDB starts here. And how I identify IDB is the IDB is supposed to be 1, and you can see that this is 1 right here. And then its length is 0044, and if you see right at the end here, this is where it ends, and it's again 0044, which is a length of 68. And that is the length of the total block, right? From beginning to the end, its length is 68. And so the length is provided, and after that, you have this link type reserved and snap length, link type reserved, and the snap length is right there. And then the options field starts. So 02 here is the interface name, which you can see is F0. And then you have, a length of 4. And then after that, it's this 9, and the 9 is timestamp resolution, which has a length of 1. So length of 1 is that, and then I guess it takes up those extra bytes to be 4-byte multiples. And then the next one is 12. 12 is the interface OS. Interface OS is Linux 3.80 generic, blah, blah, blah. And so once that ends, basically that's where the interface description block ends, and the IDB ends right there with another length field here. But if you notice that there is another 01 block right after it, and what happens is that second interface block that follows it is another IDB. So you could have multiple IDBs in Cascade, and that would capture the multiple interfaces which you can use later. Now, here's a list of all the options fields, and it's in the document. If you check it out, if you want to check it out, go look in the document. You'll see all the various things that you could add in there. The most important ones, if you look at it, is the OS, the interface names, etc. What kind of IP addresses are being used, MAC addresses, timestamp resolution, timestamp zone, all kinds of stuff, interface speeds, they can be fed into this, so you can get an idea of what the interface looked like from where the capture happened. Now, another thing very interesting I'd like to point out is that if you go to your Wireshark, pull up this PCAP and look at statistics, and under statistics, if you say capture file properties, it pulls up this nice dashboard of all the stuff, all the, so if you see here the capture in the PCAPNG, it shows you the SHB right there, and then shows you all the interfaces that were there in the file. And so I think this is very useful property. In fact, it maps nicely to the file. As we were looking through the bytecode, we can see all this stuff here, and you can see the next one, which is USB Mon 1. In fact, if you go here, you can see that USB Mon 1 was the next one, and so on. So this is very nice, breakdown of what we are seeing in the bytecode, and very easy to quickly come here and see what the various interfaces are. Now, we will cover the statistics blocks and other blocks next time, but hopefully this gives you an idea of how to read the reference document, and how if you open up a PCAPNG file, you can map them back here and see what's the various blocks doing and how they're mapped. So hopefully you enjoyed this video, and if you liked it, give me a thumbs up and subscribe to my channel. I'll continue to bring you PCAPNG, um, more interfaces down the road, and stay tuned, and I'll see you in another video. Thanks a lot, and bye-bye.